Hello, everybody. Thank you for joining us today. Today I'm going to be speaking about an application that we developed in collaboration with TCAN to measure viability, cytotoxicity, and apoptosis from the same sample well as a means to determine compound mechanism of action. So my portion of the talk today is going to address the application itself, and I'm going to be highlighting features of the Spark 10M that we use for the application. And then Katrin will be providing you with more background information on the Spark 10M and its capabilities. So I'll first start off today by touching on considerations for mechanism of action studies. And I'm going to be delving into the applications themselves by dividing them into two separate parts. First, we're going to be talking about the cytotoxicity biomarker and whether or not we can use it as a predictor for detecting the apoptosis window of detection. Second, I'm going to be talking about the idea of implementing a cytotoxicity threshold for automated injection of a Cas-based 3,7 reagent. And I will be discussing the objectives and the results for each one of these two applications as I go along in the presentation. And then lastly, I will wrap up with some general conclusions and some additional resources should you be interested in learning more information about the applications and the products that we describe here. So to begin today, cell biology research involves cause and effect. So we're testing a system or a treatment, and we're evaluating its impact on cell health. So causes can be anything from treatments to simply handling the cells in a certain way. And effects are wide-ranging, and they can go anywhere from continued to enhance proliferation, detrimental outcomes, including apoptosis or overt cell death. Assays are often used to measure these effects. You can be looking at biomarkers that are associated with things such as viability, like ATP levels, membrane integrity changes, or even apoptosis or Cas-based activity. So discovering if a treatment is detrimental to the cell health can be a difficult task, and oftentimes there's really no simple answer. And the reason is that the biological profile from any treatment is dependent on a number of factors that will impact that result that you get. And I've got those factors listed on the right-hand side of the slide here, and these are just a few, and there could be many more. On the top of that list is dosage. So how concentrated is the test article that you are evaluating? And oftentimes what we'll do is we'll address this by performing a serial titration of that compound. Exposure time, so how long do the cells come in contact with that test article? Is it hours? Is it days? Mechanism of action, if it's even known. Does that compound cause necrosis or apoptosis? And then lastly, cell type. Is it specific to the disease state, or is it a off-target cell type that you're just looking for general cytotoxic effects? So if you're using an assay to measure the effects of test article treatment, it's critical to understand that the kinetics of the biomarker that you are measuring can change over time. So which biomarkers appear when are tied to the method in which the cells are dying. And what we're showing here on the slide are examples of apoptosis on the top and necrosis on the bottom. And you'll see within each section we have some cartoons of cells that change their morphology over the course of time as cell death is ensuing. And the changes that you see are dependent on the method in which those cells are dying. And then within the boxes underneath the cell cartoons, you'll see a series of pluses and zeros and a variety of biomarkers corresponding to those pluses and those zeros. And what that's telling you is that over the course of time, when there's a plus there in our little table there, that indicates that the biomarker is present at that point in time and can be measured. So the more pluses that you see, that corresponds to the increased amount of biomarker that's measured at that point in time. And then